Okay, hi everyone, we'll move to physics where the question says construct a simple pinhole camera using locally available material that includes light-tight box or tins, frosted glass, or tracing paper to act as a screen. I think they meant frosted glass, but I'm not going to argue for now. A tiny hole made on one of the faces of the box. Reference YouTube Abbott Learner's Guide. Note: the box can be made light-tight by blackening it inside or covering the camera with a piece of cloth. Make sure you can view objects using your simple camera. So they've given us ways of making the box light tight. I'll explain why it has to be light tight later, and obviously make sure you can view objects using your simple camera. It's not a camera if you can't view objects in it. Anyway, enjoy. For the pinhole camera we have tin, paper, and lastly pin is to feature. We've got a compass I'm going to use to pierce the pinhole. Like the name suggests, a pinhole camera has a pinhole, so I'm just going to estimate the center of the tin. Just put the hole there as tiny as possible. There we go. Pinhole. So I'm going to grease the paper. As you can see, the tin is clean inside. I had to rinse it prior to this recording because it had something inside. So next I'm greasing the paper. Okay, the purpose of greasing the paper is to make it translucent such that it can allow some light to pass through and some light to remain on the screen, because the essence of a translucent object is that it allows some to pass through and some not to pass through. So if the paper isn't greased, it remains opaque, meaning the image will be formed on the screen but it won't be visible to us, and if it's transparent, all the light will pass through, hence no image will be formed on the screen. Translucent, yeah. I hear when you grease a paper and put it to dry in the sun, it becomes a tracing paper, but I'm yet to confirm. But another thing I was supposed to do, and I'm supposed to do, is to make the inner surface dark because it's currently shiny, and that might kind of distort our results. In slightly more technical terms, it causes internal reflection, which is not good if we have to get an image on the receiving end of the screen. It's supposed to be dark. So what I'm doing now to try to get the measurements of the height of the tin such that I can effectively cover the tin. From the little physics I studied this term, I think I do remember shiny white surfaces are the highest reflectors of heat. Bonus: by shiny white I mean silvered, meaning In terms of reflection, silvered surfaces reflect the most, followed by white, followed by shiny black like a polished shoe, then just black. This is also very important when talking about radiation in heat transfer, but that's a topic for another day. I'm going to try greasing it on this other side. Managed to get some shoe polish. I'm going to blacken this paper so that I can put it within there to cover the shiny surface. You can see the shining has reduced. So what I'm going to do is to get another small whatever paper that I'm going to use to cover this part. Hopefully my estimation skills are correct. Right on point. As you can see, now let's see how the performance of the actual thing. As I end this video, please note that wasn't the final bit. I still had to cover the pinhole camera with a box, just like you put your hand over your phone on a sunny day if your screen was not all that bright. So that's what I'm going to do in the next video, so stay tuned for part 2. And as usual, thank you for watching. Like and subscribe and stay tuned for the next video. This is Co-Creator 256, and as usual, peace.